Welcome back to the channel, everyone. Today, we're diving deep into the evolution of computers. From ancient tools to cutting-edge tech, it's mind-blowing to see how far we've come. We're talking about a journey through centuries of innovation and problem-solving. So, whether you're a tech enthusiast or just curious, buckle up because we're about to break it all down right here on Everything Simpler. Before sleek machines, we had simpler but ingenious tools like the abacus. Imagine doing complex calculations without a calculator, or even the Arabic numeral system. The abacus, with its beads and rods, revolutionized math. Then came inventions like the astrolabe for navigation. These tools laid the foundation for the concept of computation. Mechanical calculators, like Blaise Pascal's automated calculation, bringing us closer to computers. Each innovation brought us one step closer to the digital age. These early inventions were crucial in shaping technology. So next time you use your smartphone, remember the pioneers who imagined a world where machines solve complex problems. The 19th century saw unprecedented technological advancement in computing. It was a time of great innovation and discovery, where the seeds of modern computing were first planted. The era was marked by the birth of ideas that would eventually lead to the digital age we live in today. Charles Babbage, often referred to as the father of the computer, envisioned the analytical engine, a mechanical general-purpose computer. His work laid the groundwork for future generations of computing machines. Though never completed, his designs were revolutionary. They included concepts such as a central processing unit and memory, which are still fundamental to modern computers. The machine was programmable using punch cards, a method that would be used in computing for over a century. It featured a memory unit and a central processing unit, concepts that are still integral to computers today. Ada Lovelace, a brilliant mathematician, developed algorithms for the analytical engine, becoming the first computer programmer. Her visionary work included the concept of a machine that could be programmed to perform any calculation or task. The telegraph revolutionized long-distance communication, introducing electronic information transmission. This was a significant step towards the interconnected world we know today. These pioneers laid the groundwork for the digital revolution. Their ideas and inventions were the building blocks of the technology that powers our modern world. They imagined machines capable of complex calculations and programmable operations. Their vision extended far beyond their time, foreseeing a future where machines could perform tasks that were once thought to be the exclusive domain of human intelligence. Their vision in a time of steam engines and mechanical looms shaped the future of technology. They saw the potential for machines to transform industries and improve lives in ways that were previously unimaginable. As we delve deeper, let's remember the visionaries who dreamed of a future shaped by computation. Their contributions were not just technical but also philosophical, as they pondered the implications of machines that could think and learn. Their ingenuity laid the foundation for the digital age. Today, we stand on the shoulders of these giants, continuing to build on their groundbreaking work to push the boundaries of what is possible with technology. The early 20th century marked the shift from mechanical to electromechanical systems. Herman Hollerith's tabulating machine, using punch cards, revolutionized data processing. Hollerith's company later became IBM, synonymous with computing. The tabulating machine demonstrated the potential of electromechanical devices for large-scale data processing. Analog computers, like the differential analyzer, solved complex mathematical problems. These machines advanced scientific research and laid the groundwork for digital computers. The transition from mechanical to electromechanical computing was significant. Electrical signals representing data and sophisticated mechanical components paved the way for digital technology. This era ignited a technological revolution that changed the world. As we move forward, remember the significance of this era in shaping modern computing. The 1940s marked the birth of electronic computers, a revolutionary era that transformed the landscape of technology forever. These behemoths, often taking up entire rooms, represented a monumental leap forward in computational power and capability. They were the giants of their time, both in size and significance. The ENIAC, developed during World War II, was used for calculating ballistic trajectories, a critical task that showcased the potential of electronic computation in military applications. These first-generation computers relied on thousands of vacuum tubes, which were the heart of their operation. Each tube acted as a switch, controlling the flow of electricity to perform calculations. Vacuum tubes were bulky, generated heat, and were unreliable. they often burned out, requiring constant maintenance and replacement by skilled technicians. Imagine a room full of these, with technicians constantly replacing tubes. The environment was hot and noisy, a stark contrast to the silent, cool operation of modern computers. Programming involved physically connecting wires and setting switches. It was a labor-intensive process, requiring meticulous attention to detail and a deep understanding of the machine's architecture. Despite these limitations, these computers proved that electronic computation was possible. They were the first steps on a journey that would lead to the powerful, compact devices we use today. They enabled complex calculations, leading to breakthroughs in various fields such as science, engineering, and mathematics. These early machines laid the groundwork for future innovations. The first generation of computers paved the way for smaller, faster, and more efficient machines. Each subsequent generation built upon the foundations laid by these pioneering devices. They were the pioneers of the digital age, setting the stage for the technological advancements that continue to shape our world today. The late 1940s introduced transistors, marking the second generation of computers. This was a revolutionary period in the history of technology, as transistors replaced the bulky and less efficient vacuum tubes that were used in the first generation of computers. Transistors were smaller, faster, more reliable, and energy efficient than vacuum tubes. They consumed less power and generated less heat, which was a significant improvement over the previous technology. This transition allowed computers to become significantly smaller and more powerful. The reduction in size meant that computers could be used in a wider variety of settings, making them more accessible to businesses and educational institutions. Second-generation computers could now fit comfortably in a large room, unlike their predecessors, which occupied entire floors of buildings. This made it easier to integrate computers into existing infrastructures. High-level programming languages like Fortran and COBOL made computers more user-friendly. These languages allowed programmers to write instructions in a more understandable and efficient manner, which sped up the development of software applications. Magnetic core memory, a faster and more reliable alternative, boosted computer capabilities. This type of memory was non-volatile, meaning it could retain information even when the power was turned off, which was a crucial advancement. Computers were used for a wider range of applications, from scientific research to business data processing. This versatility demonstrated the potential of computers to transform various industries and aspects of daily life. The second generation marked a turning point, transitioning computers from specialized tools to versatile machines. This era saw the beginning of computers being used in more common and practical applications, setting the stage for future innovations. This era laid the foundation for rapid advancements in computing. The improvements in hardware and software during this time were critical in shaping the future of technology. It brought us closer to the computers we know today. The groundwork laid during the second generation was essential for the development of modern computing devices. The second generation was a significant step in the history of computing. It not only improved the technology, but also expanded the scope of what computers could do, making them an integral part of modern society. The late 1950s saw the invention of integrated circuits, ushering in the third generation of computers. ICs packed many transistors onto a single chip, shrinking the size and cost of computers. This miniaturization made computers smaller, more affordable, and accessible. The third generation also saw the development of operating systems. Users could now interact with a more intuitive interface using keyboards and monitors. Disk storage replaced bulky magnetic tape drives, offering faster access to data. The third generation marked a shift towards personal computing. Computers were no longer limited to large organizations. This era laid the groundwork for the personal computer revolution. It made computing accessible to everyday people. The 1970s brought the rise of personal computers. The microprocessor, a single chip containing the CPU, drove this revolution. Smaller, affordable computers like the Apple II and IBM PC became popular. Graphical user interfaces replaced command line interfaces, making computers more intuitive. The Internet, initially for researchers, fundamentally changed communication and information access. The World Wide Web made the Internet accessible to the public. The fourth generation brought a paradigm shift in how we live and work. It laid the foundation for the digital age. Computers became extensions of ourselves, integrated into every aspect of life. The personal computer revolutionized the technological landscape. The fifth generation of computers is defined by AI, mobile computing, and connectivity. Computers are now partners, capable of learning and making decisions. AI transforms industries, from healthcare to transportation. Smartphones and tablets bring unprecedented mobile computing power. Cloud computing offers limitless storage and processing power. The Internet of Things connects everyday objects to the Internet. Quantum computing holds potential for revolutionary advancements. The fifth generation blurs the lines between physical and digital worlds. Technology is increasingly integrated into our lives. The future promises exciting advancements, from brain-computer interfaces to bio-inspired computers. The journey of computing is ongoing, driven by human ingenuity. The possibilities are limitless. The future of computing. Thank you for joining us on this incredible journey through the evolution of computers. From the humble abacus to the potential of AI, it's been an incredible ride. The journey is far from over. What will the next generation of computers look like? What problems will we solve? What world will we create? Don't forget to like, share, and subscribe for more fascinating tech content. Let us know in the comments below what tech innovations you're most excited about. And as always, thanks for watching Everything Simpler.